Let's start with the satellite view of the. How about one of Pete's week-long satellite views? Where are those, Pete, down the bottom? I like the infrared. Yeah, so this goes all the way back to the 22nd, sometime on the 22nd. Is that right, Pete? Does it start on the 22nd? Or does it start on 20th? Okay, so it is it's a whole full week. Okay.
Starts last Saturday at 0Z.
So here's the infrared, beginning last Saturday, 0Z, right up to the present time, or close to it. And you can see it's been a lot of activity across the continental United States, adjacent countries to the south and north, and then the waters as well. So let's wait till we're back toward the beginning. This is getting close to the end right now. So here's the beginning, and the southwest coast of Mexico was impacted by Hurricane Willa, and Hurricane Willa was putting itself together early in the weekend last week. And there it comes, the eye's gonna pop right out. That was a Category 5 storm for a while, I think, but it was Category 4 when it hit land. And then watch what happens when it makes a real encounter with the mountains of southwestern Mexico. It doesn't last very long in the infrared as an inland disturbance. It really just disappears, although the circulation associated with it doesn't disappear anywhere near as fast as that. And this second development that's going on here in the central United States yesterday and today seems to have a relationship to Willa at some initial stage. But it's we had a really nice discussion of this storm yesterday at 4:52. Jake is not here, right? No, he's not here. Jake gave a really nice forecast discussion of it. And it doesn't really get itself well organized, but it is going to be associated with some major precipitation along the East Coast, everywhere from DC, Hatteras area, all the way up to the Gulf of Maine. And I'm not saying it's former Hurricane Willa. I'm saying it's not unrelated to former Hurricane Willa. There's disturbances in the mid-latitude flow that make their way southward and seem to phase with whatever might have been left of it. And that is what gets poorly organized over the next couple of days along the East Coast. But sort of an interesting storm. So that's one thing we'll talk about a little bit, or at least set it up a little. Then earlier in the week was this massive event over maritime Canada, fueled by a really roaring subtropical jet across the southern United States. And so look at this cloud mass going up there, ridge building south of Greenland. So there's a huge anticyclonic flow now over the North Atlantic, and it had something to do with the development of that storm, which of course in turn had components from high latitudes as well as low latitudes that kind of were involved in that development. So it's been an active week, and time being as it is, we can't spend a couple of hours diagnosing all these different events. But I would just say that if you're in the habit of looking at weather maps every day, which is a good habit to have, then you should definitely start doing that now at this time of year. If you've been bored by September and maybe the first half of October, if you're not interested in the tropics too much, it's getting more interesting now. And the interaction between extratropics and tropics remains very interesting, especially when the extratropics start to rev themselves up. And last week I sort of stupidly declared that the tropics were dead, and that was hours before Willa got herself organized southwest of Mexico.
A mission accomplished moment?
Yeah, yeah, right. It was on an aircraft carrier. Tropics were dead. But of course, I knew I was likely to be wrong. The person we're referencing there did not know and still doesn't know whether he was right or wrong. But I certainly said it in somewhat facetious manner, but it was funny to have it just hours later proven wrong. So
we go back, if that's possible to stop that. The other interesting thing was on Friday or Saturday, a little burst of snow.
Oh, yeah, that was great. And we did talk about that at length last week in the discussion. And that was a beautiful example of a very nice isotropic disturbance at 500 millibars coming down in northwesterly shear flow. It was a perfect example of PVA by the thermal wind. And man, was it just about exactly right. And in fact, somebody told me afterwards, maybe Pete and I were talking about this, the weather service Friday afternoon was saying showers, 42 degrees temperature and all that. And I was saying, no, we're going to see our first major snow on Saturday morning. It was a major snow event. It's a major snow event. You can't, who here would argue that Saturday morning was not a major snow event?
Would argue that it was.
That would not.
It was not flurries.
It was not flurries.
Okay, it wasn't flurries, but
all right. First of all, were you here?
Yes, I saw it.
Okay, you were here. All right. So you saw it, right? It was a blinding blizzard of snow and leaves mixed in, which never happens. That was really awesm.
Right.
Okay.
Plus SN plus L.
But anyway, the thing that was interesting about this was Friday. I wasn't aware of this when I was talking about it myself, but the weather service was insisting rain. It was going to be all rain. And I thought, no, that's wrong. They're being goofy about this. So and when I woke up on Saturday morning at, I don't know, 8:30 or something, look outside, it's bright sunshine. I thought, oh no, this is a total bust. And then within an hour, you could see the clouds coming in from the northwest, just as they should have. And that was perfect. And then it snowed like crazy.
I should do a rooftop camera loop of that.
That was just awesome.
Temperatures dropped from, I think, the low to mid 40s into the low 30s.
Yeah, I think we were 30 degrees when the snow ended. It was probably 33 while it was at its peak. And a lot of sublimation going on. So there it is, right there. That was just a great event. And you had to be right here in the southern part of the state to get it really the best. But you can notice that disturbance, as it comes through, it definitely has a strong cyclonic circulation with it as it moves across Pennsylvania into the Gulf of Maine. But it never really gets linked up with anything. And so it kind of fizzles out in this strong southerly flow. But it lasted a long time across the Great Lakes states and then to the east. So that was really pretty interesting. And then off the coast of the western United States, we've had some interesting weather this week. So I don't know if we don't have a loop for GO 16, but we can look at the current GO 16 to take a look at what's going on out there.
16 or 15?
Whatever the one up.
The west, right?
I got my numbers wrong. Yeah. And this has been an active week too. We've been looking at it a couple of times during 452. So we got the strobe effect for some reason here, which is really frustrating because rats. I think that's going to be true on that one too.
We got bad imagery somehow.
Then let's just get an image so I can at least point out something about it. So this image kind of sums up a lot of what we've seen. So first of all, early in the week, there was a major cyclone that made landfall on the south coast of Alaska. That had a sea level pressure down in the mid-960s or something. And the broad baroclinic zone associated with that first development is still lingering out here over the Central Pacific. There's Hawaii. And you can see there's been little swirls along it that have developed it's a broad upper trough. You can almost see it just by looking at the satellite picture, a broad upper trough over the Gulf of Alaska. Embedded within it are local spots of enhanced vorticity. Here's a small one that never really got its act together to the extent that the one to the southwest did. And then there's another one just north of the Queen Charlotte Islands that spun up on the baroclinic zone and probably is responsible for some precipitation in northern British Columbia. This is a major event, mostly convective in its origin, but tied to some upper vortex. But you can see how the convection has really put itself together into a beautiful comma. And on the periphery, the subsidence squelches all other comers for convective clouds. But in the middle, where it's cold, aloft, there's a nice collection of slightly organized convective clouds. And if we didn't have the strobe effect, you could watch that rotate really quite nice. So this is an interesting development. It's the kind that probably pops up rapidly and is a real hazard to navigation, I'm sure, out over the ocean. And then there's something going on at about the dateline that's quite impressive as well.
Are you going to go over to YouTube? I like to call it YouTube, but YouTube.
East of
Hurricane YouTube.
Oh, U2, yeah, it was a Category 5 storm. Yeah, we should take a look at that too, yeah. That's definitely. Sims has some decent stuff. I don't know if this is.
Think over Sims side, that'll work.
Yeah. So here's U2, which may be Category 5 now, but it was.
I think it's
was
starting the
yesterday.
weekend, but just get the IR.
Yeah, it's weakened down to Category 4.
IR.NHC.
Okay. Right, that one.
You can animate that too.
Look at that storm.
Go ahead and animate it. You can just, I wanted to point out, notice it's lost the symmetry to the outflow now. This is why it's weakening to Category 4. It
No,
cannot push it.
I don't know what you mean, so.
Well, the outflow was going 360.
Oh, in all directions?
Now you see the outflow is favoring toward the jet.
Oh, I thought that was true yesterday. It wasn't? It was just.
Well, it
everywhere?
started yesterday, that's why it started weakening.
Okay.
And once that's what happened with Florence. Once
Yeah.
once the outflow becomes asymmetric during the downglide, they're not going to keep getting stronger.
This is the northern Philippines, Taiwan's over here, and this is one of the southern islands of Japan, right? So Japan's
Yeah, you
up
can
here.
back that out to 8 kilometers.
Oh, you can? Yeah, let's do that. I like a bigger view so you can see where it sits. Yeah. Oh, thanks. Oh, yeah, there we go. Yeah, so here's Luzon, Taiwan, and then Japan. So,
And I'll be in Shanghai next week.
and that's right about here, right?
Yeah, right about it.
So that's perfect for you.
Well, not quite perfect. It needs to go a little further north. And
Not
the outside.
perfect. Where is the subtropical jet right here? This is latitude 25 or 30.
You can see it button up against it there.
So right in here.
Yeah, I mean, the Cirrus outflow kind of stops at it.
And then there's an extratropical disturbance. Yeah, that's 30 degrees north. Sorry, I can see it. You can't see it, but that's 30 degrees north. So there's an extratropical disturbance further to the east that is changing the baroclinicity to the south anyway, at least what it appears to be. Some cold advection south of 30 degrees north. And as the hurricane is moving slightly northward, but mostly westward. So it's an interesting.
But that's a super
situation.
typhoon.
Yeah, that's a major event. And so where's the extent of the low PV for this big thing? Is it this far away? Or is it maybe just this far away right now?
Okay, probably extends further to the east.
Yeah, okay, so it's a
I
big
think
pool of low
that-
Pete,
PV.
why don't you put that animation up you gave me from Wednesday? You sent it to me in an email?
Yep. Where it is.
That's a great animation. Man.
It's animation of,
It's the IR.
Of you two, the wall going, the eye going over Saipan,
Tinian?
CPN, SIAPN.
Okay, second.
Saipan.
This is the 8th anniversary of the megastorm, October 26, 2010.
Mm-hmm.
The second,
Oh, I'm waiting to see what's
Lowest
going to
sea
happen
level
with this
pressure.
one.
I don't know if it's connecting the right way.
Well, I mean, yeah, I don't know. It does seem to be broken up into two parts.
And there was one earlier this year we talked about on a Friday, wasn't it? It was a super typhoon that that just went straight into southern China and it had no impact. It was too far to the south. It wasn't enough recurvature to the north at the last part of its life cycle. I wonder if
Yeah, look at this.
YouTube's going to do the same. Look at that. That's amazing. So is this Saipan?
Yes. right
Wow.
there.
Oh, this is Saipan.
Yeah, okay. It's an American
Man.
island.
Yeah.
Oh, man.
It says, wait, I gotta go a little further north.
Wow. That is incredible. So what were the odds from there? Does anybody?
They said, they said they were Cat 4 gusts to Cat 5 type winds.
Wow.
The wind instruments were damaged. They lost the instruments.
Yeah, they lost.
Well, in fact, wasn't this the story I saw somewhere, maybe it was on CNN? This is, yeah, it's American territory, and so this is the strongest impact of a hurricane this year on American soil. Yeah, and it's kind of weird, people are caught by surprise, but it's out in this.
It's a gorgeous storm, though.
Yeah, that's really something.
See how the outflow's going to the south now?
Yeah, that's right. Yeah, it's
And
very
it's like-
different. Wow, awesome. Perfectly symmetric, almost. I mean, God, that's crucial.
Yeah, this is from the Himawari. This is the kind of imagery we'll be getting from GOES 17 once it starts up again at the west position.
Do we have a little IR with it? Do they have a problem with the subject?
Yeah, they've addressed a lot of that. I think they said they're going to end up with about 97% of the expected imagery. It'll vary at different times of the year.
Yeah, so it's an exciting time of the year because, and Greg pointed this out many years ago to me, because you've got still tropical activity, but a southward moving jet structure. And so the possibility for communication between the two is enhanced in late October as opposed to late July or late August. And I think that's true to some extent in the Atlantic Basin too, though to a lesser extent than it is over the Pacific Basin. And then Pacific Basin influences of tropical disturbances on the subtropical and polar jet have implications downstream in time and space for predictability. So that gets to be a major issue too. I don't know if the predictability issues spike at a certain time of year and then kind of wane just a little bit or not. That would be interesting. Because if this were really a major factor that leads to certain predictability issues, then you'd think that once the tropical cyclone season does die down, and in fact, it does die down, even though not last week, it does die down. Does that become a little bit more of a predictable situation for downstream events? I don't know. So let's go to the Super Peats and take a look at our situation around the country and around adjacent waters. That's why it's a Super Pete. You can get farther out. So first, to look at the West Coast, we had our nice convective event going on here in this deep trough. As you can see, there is a deep trough south of Alaska and the British Columbia coast. And it's pretty cold. It's at least minus 30. The hesitancy to put a minus 35 in there. It's probably not as cold as minus 35, but minus 30 is pretty cold. So that's a moist, unstable lapse rate over that part of the ocean. 40 degrees over 5 kilometers gets you about 8 degrees C. And if you've got saturation, you're going to be freely convective in that regime. So that's nice. And it's strongly forced, there's strong curvature, and there's even variations in the curvature, cyclonic and then acyclonic. Strong baroclinicity indicating strong winds. The geopotential height gradient testifies to the same thing. So lots of reasons why there's dynamical forcing and correct thermodynamic situation out in that location.
Yeah, I
to
want to
really
point
have nice development.
another thing out. This is a good example of how a Rex block is taken apart. It's being disassembled at this very moment because you can see the low down there off of Baja disappearing.
And Rex is the high over low?
Yeah,
Oh, okay, yeah.
we had it last week, and now it's being sheared off the top.
So this thing sags southward and it's a strong jet. that pushes
Once
it
this
southward.
happens, we move into a progressive pattern.
Yeah.
Where you have continuous shortwave, so we should see a lot more activity around here.
And that seems to be true in the forecast. It's certainly
So-
true. I'll just say, the corporate Dodgers will sponsor Game 3 of the World Series tonight down in this location, and it'll be pretty warm. It won't be the record 103, which was Game 1 last year when they lost to the valiant Houston Astros, but it is, it's going to be warm down there. Pretty high heights, 5907 off the coast. So it's a broad and very wavy flow. So there's a broad trough off the coast of the Pacific Northwest, and another broad trough in the central U.S. Remember, we had Willa come across, whatever's left of Willa come across the Mexican plateau, got destroyed by the plateau, but perhaps something remains in the PV field at some level. It's hard to detect on a series of just 4 maps. It's not evident at all at 500 millibars. However, there is a polar trough sitting over the Mississippi River along the border with Illinois and Missouri. So that's an interesting trophy feature. Decent curvature and not much speed variation around it. So any ageostrophy that's generated will be a function of the curvature mostly at this level. And so here's the anticyclonic and here's the cyclonic curvature. So, upper level ageostropic divergence over southern Indiana, parts of north central Kentucky right now. And then we'll see when we go further down, there's more structure to that than just the upper trough. And then the broad upper trough, cold upper trough that we've seen funneling cold air off the coast of the northern part of North America all week with stratocumulus and so on, and finally reaching cold frontal boundaries, which are out from Bermuda up to Greenland, is really nice. Look at this baroclinic structure. This is 10 degrees in between these 3 isotherms. And it's cold as -30 over a wide expanse of northeastern Canada, and uniformly about -30, and then even colder as one moves to northern Quebec and into the archipelago, -35. So that's a really impressive upper disturbance, and equally impressive is the ridge. Look at these heights, 5849 for the geopotential height maximum at the latitude of the mouth of the Labrador Sea and just to the southeast of Greenland. So this is a major ridge that's building in the Atlantic. Melissa, I don't know if this is one of the nice examples of early autumn blocks up there, or is this kind of the way that things can go there?
Yeah, I ignore the Atlantic so much, sadly. But I mean, I think this actually reminds me of the situation we saw forming the East Pacific block last week, where
Oh, interesting.
the kind of negatively tilted cyclonic feature upstream is just kind of losing out to the anticyclone that's helping produce.
And we saw on the satellite picture vivid evidence of, intrusion of the tropics to high latitudes on the eastern side of this upper trough. And so that's certainly a factor in building the ridge.
Well, that ridge is a tropical plume at the high levels. That's what we were just looking at in the previous.
We were right. Yeah, that's right. So it's dragged in, and earlier in the week, we had, you could see it in the cirrus clouds in the satellite. The subtropical jet was about 180 or so knots, right about in this latitude, northern tier of the southern states. And it's kind of wrapped around this deep trough. So there's a classic example of ridge building by interaction of tropics and extratropics.
Right, so John, another thing is I'm imagining there's probably just to the east of that 500 millibar trough, pretty significant surface cyclones, I imagine, is developed.
Yeah, I would guess probably right around the
Exactly.
mouth of the Labrador Sea. Yeah, I think that's probably right. And here's the 500 millibar version of the occluded thermal ridge, so the cyclone's probably right in there. So
Right.
let's go down, let's go to 700 and I'll keep the pointer there and see what we see at
And as
700.
we bring that up, we had a comment from actually Nuo Chen, so from
Oh, yeah.
China. She's watching That's right now, she
I'm gonna
mentioned.
see
the
her,
users-
I'm gonna see her tomorrow.
Right, yeah, the YouTube's track was hard to predict. She thinks that the ECWF and the GFS both got it wrong a few days ago in terms of that track, so it's something
Yeah.
to watch
Oh, yeah.
in the forecast. Thanks for the comments.
Yeah.
Is she worried about it? She's in Shanghai.
So we were right up here at the mouth of the Labrador Sea, and one can see the further down you go, the more obvious the paraconicity starts to look like an extratropical frontal structure. Here's the cold front. That was not so hard to see at 500. The warm front is a little bit more obvious at 700 millibars than it was at 500 millibars. And the occluded thermal ridge pointing right back into the west coast of the Labrador coast. And you've got this low geopotential height minimum, 2671, pretty intense cyclone there in far northeastern Quebec. And here at 700 millibars, you see even more definition to the trough over the central United States. And there's a weird thermal field. It looks even weirder, I think, at 850. But one does not see any obvious circulation associated with a prior disturbance that migrated across Mexico. And so it's really, this is the upper disturbance within which whatever's left of Willa has to put itself together. And it struggles to do so, as we'll see in the forecast. It doesn't really get its act together.
Can we check how tilted that cyclone and anticyclone are? Because I'm thinking if it's,
These,
like go back to the upper
So
levels.
go to
again.
500,
Let me get
Yeah.
you reset.
Oh, does it get all?
ready?
I just wanna get it from there. That's it.
Okay,
You wanna go to 500?
yeah.
Yeah, so they're vertically stacked. so
Yeah, they are pretty much, aren't they?
That's probably gonna help, the anticyclone kind of block the cyclone from developing or propagating. It's probably gonna go north and weaken.
Yeah.
Just like we saw in the cyclones last week in the same situation.
Yeah, that's right. The satellite picture showed that too, the movie that he made. You can see those things just go straight up and southerly flow, and then they just die over Greenland.
Yeah.
You can't make it around the bend. Yeah, that's a good point. This is getting to be equivalent barotropic. And even the thermal advection field at 500 millibars suggests that now in retrospect, but it often does that high. So it's not something that you can use just as your first guess. So let's go down to 850 and see what this thing looks like in the central United States. And you can see, this is why I say it's kind of hard to really, it's even at, let's do this. That's at 850. Let's go to 700 again. See, this trough is tilted to the north and west. And perhaps that's not so unusual. But anyway, back to 850, we'll see the minimum geopotential height displaced as it is to the south and east. It has an interesting thermal structure. This thing has pretty decent cold advection region on its western side and a reasonably strong warm advection region over Georgia, Alabama, parts of South Carolina. And it's genetically so because the winds are stronger on the southern side than they are on the cold side. So one imagines the warmer isotherm catching up with the ones to the north and the gradients getting intensified. So some part of the vertical motion and precipitation that was evident in this location, just remember, we never looked at the radar, but we saw it on the satellite, the cloudiness, is a function of chronogenesis, as Jake pointed out to us in class yesterday. And then some function is going to be a function of moving the upper vorticity, weak though it is, across this region by a thermal wind that's more or less westerly, but maybe southwesterly to northeasterly to some degree. And so one gets a contribution from both wave scale forcing for vertical motion in the northern periphery of this region, and maybe frontogenetic forcing for ascent over the southern portion of it. And meanwhile, here's our cyclone at 850. Look at the frontal structure you can see here. Beautiful, long and occluded thermal ridge back into the center of the geopotential height minimum, which is only a kilometer above sea level, effectively, over the mouth of the Labrador Sea before you get to 850 millibars. This is a really deep disturbance. Strong warm frontal structure on the backside wraps behind it, and then the cold frontal structure comes back down, as we saw in the satellite picture, intersecting the coast, if it does at all, somewhere in the southern part of the Carolinas. So a pretty interesting initial setup going on here at throughout the column. And you can see that the broad troughiness in the central United States is negatively tilted, which is interesting. And whatever might be the tropical remains of Willa are kind of able to invade on that southern side of that disturbance.
So John, I think,
Southerly flow.
I'm sorry to interrupt you. I think the remnants of Willa, none of the lower, even perhaps maybe barely the mid-tropospheric part of it got across the mountains. I think it's really whatever was left of the plume that it was perhaps that it created, or the mid-level circulation was evident at 500 millibars, may have just barely crossed. So I think anything at the surface you're not gonna see much of the surface.
Yes, that's a good point. That's a good point. And so, in fact, I don't think we looked at 300. Why don't we take a look at the 300 millibar map now? I like to start at 500 and go back to the upper level. So here, one gets the idea that the hurricane made landfall here a couple of days ago or 3 days ago. And so there is a flow from that direction up to the southern periphery of our disturbance, but there's absolutely nothing suggestive, even at 300 millibars, of that event, with the exception of perhaps the wind speed maximum there. And if we go to 200, we might see a fairly substantial subtropical jet. Well, it's not any more substantial over these states.
But I think the thing
than it
off
was
the East
anywhere else.
Coast, you know, up at the East Coast there, I think that's
Yeah.
more the center of the plume. That's the center of the plume of Willa there. And so that whole subtropical jet there is bounding the outflow plume from Willa. And the dynamics that are going to be important will come from the secondary circulation probably around that jet load there.
We could look at the development of that maybe by looking at the animation.
Yeah, okay, let's
I
do
don't
that.
know what's a good level, 300 or
Well,
500.
300,
Or 200 if you want to see that jet.
Yeah, so let's say 200. This goes back to last week.
Yeah, so this is, can you move it up a little bit, Pete? So I can see the bottom too. Okay. And this starts on, a week ago today. So this is, and the hurricane wasn't even organized yet. It was just convection out off the Baja, okay? Or maybe further south, yeah. So the hurricane's gonna make landfall here on Sunday. This is a subtropical jet that's coming across before there's a hurricane.
Yeah.
And then the hurricane potentially can pump up the eastern portion of that. Is that true? Is that what happens? Doesn't seem to. Maybe right there. Okay, that could be. Of course, go back one, Pete. I would argue that there's a chance that, maybe one more, there's a chance that that enhancement is simply a greater confluence of a polar and subtropical jet stream.
Mm-hmm.
So when we go to the next time, this little piece right here over the Dakotas and Minnesota is further to the south, there's more of a confluence there. That might happen simultaneously with outflow from the hurricane. But this upstream jetlet, well upstream of the hurricane, is interesting. And let's keep going. And then it just becomes an extended tail to the subtropical jet. It's hard for me to know for sure whether or not the hurricane
It
has a
doesn't
major
really look
influence
like
here.
much is coming directly up.
Yeah. Okay, so there we are, I think, at almost at the current time, yeah, so it doesn't seem obvious anyway, even at the subtropical jet level, that there's a strong connection between what happened on the coast of Mexico and what's going on here, so. But this event, I think Michael's gonna talk about it in the forecast, Jake in our class did yesterday. This event struggles to get better organized, because there aren't really a lot of nice, strong pieces for subsequent development laying around. The upstream trough is weak and gets weaker. The low-level barotonicity is modest, and it gets worked on by the circulation that does develop. So that is one of the factors that actually plays a role in the development. I think one of the main things we're going to see is that there's a region, and you can trace it over time, there's a region of really intense and localized warm advection in the lower troposphere that I think is associated with a precipitation maximum that persists through forecast panels, and it's easily diagnosable. And that might have a role to play in shaping the broader environment into one that's, for a while anyway, capable of sustaining some weak cyclogenesis, but not for long. It doesn't look like.
So is this thing coming in on the west subtropical or?
This right here,
Yeah.
I think it's probably a combination. This here on the northern side is a polar jet, I think. And then
But
this
you're
thing
up
here
pretty
is probably
high
a
there,
confluence of the two.
Yeah. Hey, go look at the 300 at that jet. See what that.
So that's 134 and 200. It's stronger.
Stronger.
Yeah, so I think it might be a polar jet feature. And this one here is equal strength. They're both about 169 or 166 knots. So it's a pretty strong jet. So I guess that's all I have for the current ops. So,
All right, thanks, Tim. So just spurred on by our discussion, I'm gonna take a look, to go to the forecast models. GFS will scroll down a little bit to upper dynamics, go to the 2 PBU, pressure and wind. Unfortunately, this doesn't cover the broad sweep of the region we've been looking at. maybe go back to 72 hours. I don't know if that's going to be far enough back to capture the landfall or the remnants of the landfall. I guess this might be it. So this is another depiction of what we're looking at in the upper troposphere on the isobaric analyses. This is 3 days ago. And I believe that would be Willa at this point. And you can see this broad area of higher tropopause, so lower pressures along the dynamic tropopause. And we let this just step this forward in time. You see the remnants of Willa crossing over Mexico. Not much. It's like the plume associated with it stays really well to the south, but it kind of arches up a little bit over the central part of the United States. But the remnants of Willa have long since gone. This is a mid-latitude cyclone that's getting developed. And this is at what time? Just trying to make sure. We're now at 0Z today. Well, so 12Z today. So we can see our surface cyclone just a little bit to the southeast, 850 millibar circulation that Professor Martin was just talking about. Again, this broad area of higher tropopause, which is going to be tied in some ways to the last vestiges of any of the outflow from Willa, but well to the south. So not much made it across the mountains of Willa, at least in the upper troposphere. It might be arguable that this ridge that we see here is in part tied to that. But this is pressure, not potential temperature, or some other conserved variable in the diagonal tropopause, so it's a little bit difficult to track them. But what we're going to be watching as we go into the forecast are going to be a couple of features. One is the surface cyclone that's depicted here. We're going to see that there is some organization of the cyclone as it moves toward the east coast of the United States. And for our weather this weekend, we're going to be watching the emergence of a feature in a northwesterly flow, westerly, and then eventually northwesterly flow that's going to come across southern Canada and give us some precipitation. Just for the purposes, since we have this map up, let's step ahead a little bit on this over time. This is 12 hours in the forecast. You can see the emergence of a cyclone along the east coast. We'll look at this in a bit more detail. And we can keep going forward in time. Please be to 24 hours, deepened as it moves to the northeast. A nice upper trough forms just to its southwest. You'll also note on the dynamic tropopause some warming in this region, which is indicative of the heights beginning to develop. Some of it might be due to diabatic processes. At 36 hours, we go further forward in time. And this is now at 48 hours. This is when a little bit of a trough-like feature is going to be going by us, producing some showers on Sunday. So if we step back, we can trace the origin of this. That's what we'll be watching with the forecast. Just making it on shore this morning in the forecast. So let's go to, we can go to the, try to get on 5. I'll just say this is, and go back to the current run, please. Couple clicks back. If this is now updated, hopefully click on the 0. Hopefully, yes, we got it. All right. So this is the current surface map, at least at 12Z this morning. Again, we saw the surface cyclone. We used the GFS analysis that shows up a weaker cyclone that's located over the southeast United States. You can see a broad anticyclone that extends from Hudson Bay all the way across the northeast United States into the mid-Atlantic. And this is sort of a classic type of setup you might see or expect to see later on in the fall. We actually are in the fall now, with a cold air damming that's occurring. This cold air sort of creeps down the eastern slopes of the Appalachians. And that's going to help enhance the baroclinicity across the southeastern part of the United States. And so that's going to also favor some, we'll see, we haven't looked at a radar yet. We should probably go back and look at that. And if we could keep this and just bring up a radar, look at the current precipitation. National view, please. So you can see in the radar, even though we have our surface cyclone that was located at 12Z, so 7 a.m. this morning over Missouri, you can see most of the precipitation is well to the east of it at this point. So the precipitation again extends all the way from Georgia all the way up into northern Virginia early this afternoon. Some pretty moderate, perhaps heavy precipitation there, and maybe a bit of a squall line, or maybe this is evidence of a cold front type trough that's moving across the Florida Peninsula this afternoon. So broad area precipitation from light precip over us, precipitation over us, and some precipitation moving into the western part of the United States this morning. So this is about to set the stage for, I think the forecast we'll see are in the order of 1 to 2 inches of rain over the northern Mid-Atlantic, which is an area that they've had lots of rain, one of the wettest years on record. Okay, so we know the precipitation's occurring. Let's go back to the maps. And what I'm gonna do, go back to the, let's go back one click, and I'll go to the normal order of things that I like to do. We'll go to John's favorite map, the meteorogram, our favorite chart.
Is that meteorogram?
Meteor, even hard to say. So we see temperature, we see dew point, and we see precipitation. So the forecast, over the weekend, looks relatively dry until we get into Sunday, early Sunday morning. We're expecting a little bit of light precipitation. Tomorrow is forecasted to be a little bit cooler than today. We'll try to look at that with some leaf cold convection over us, perhaps. And then Sunday being just a tad warmer, even though we have the precipitation, so that's something we'll watch. We'll probably staying only in the mid-40s, perhaps. If we look at our time height sections for this, and time running from left to right on this, yellow lines are lines of potential temperature, so isotropes. The red is relative humidity, and you can see we're going to have relative humidities in excess of 90% over us. This looks like a fairly cloudy weekend for much of the weekend, but not much in the way of precipitation. And we see things begin to dry out a little bit early Sunday, Saturday night, early Sunday morning, and then we get a little bit of plume of higher values of relative humidity, which perhaps can be associated with weak ascent and the approach of an upper trough. You can see the heights begin to look, the dynamic triple pulse begins to lower over us, which is indicative of that upper trough that we saw in the tropical tidbits set of maps.
Yeah, and it's digging too. At the end of the period, it's still digging because the subsidence is right in the middle of it. It's still going to come down.
Subsidence in the middle, and so it's kind of a curious thing. We have a cold advection occurring. You can see this slight banking of wind with height, but also the depression of the tropopause and these isotropes kind of poking up a little bit more. So there's some ascent this week, and then it begins to dry out again as things go by. So just a burst of the precipitation early Saturday morning or Sunday morning in the form of showers is how I would look at this. But the fact that we stay in this zone of really high relative humidity doesn't get any exaggeration, but we're going to be very just a cloudy weekend. I imagine it's coming up for us. All right, let's go look at the evolution of the surface maps. We'll go to 12 hours, please. For 12 hours, this is the accumulated precipitation. You can see in that 6-hour period ending at 0Z this evening, we're looking at over an inch to an inch and a half of precipitation just off the southeast coast of the United States. Really heavy precipitation is forecasted over parts of Virginia, and you can see that much of it is aligned just to the east of the Appalachian Mountains, and so you have this easterly flow, geostrophic easterly flow, hitting up against the topography. It's forced to rise, and that's going to contribute to a significant amount of precipitation there. The surface cyclone at this time is expected, the one that was over southeast Missouri is weakened, and we see a sort of a principal cyclone beginning to develop off the South Carolina coast. And these are areas in both not only in Virginia but in North Carolina that got a lot of rain from Florence earlier, and so those grounds are still pretty wet, and so there's probably the risk of flooding, I imagine, in parts of the Carolinas. For us, again, not too much to worry about otherwise over us. Let's go ahead another 6 hours to watch the development of the storm, or 12 hours. So let's actually go back, Pete, to 0Z, go to 30 hours, 6 hours ahead. Oh wait, I'm sorry, what am I doing? 18. Can't count. 1,003 down to 1,002, so this is modestly deepening. Again, lots of precipitation out of the warm sector of this developing cyclone. Really intense precipitation. Again, another 6-hour total over the eastern shore of Maryland, Delmarva, and central Chesapeake Bay region. About 1.5 to 2 inches of rainfall in this region, again, with that deepening cyclone. But it's deepening modestly, a strong high to the north of it. Sort of a nice setup if this were in the winter for perhaps a significant snow event, but obviously it's way too warm for this to be frozen precipitation at this point over the mid-Atlantic. Let's look at some diagnostics for vertical motion. One, I think in your class, did I talk about the Q-vector?
Yeah.
Okay, so let's look at the Q-vector convergence. We're going to go to 12 hours, then 18 hours. Take a look at that. So kind of a messy map. It turns out actually where we see some of the heaviest precipitation early on along the east slopes of Appalachians, Q-vectors aren't going to diagnose that. In fact, this is suggesting subsidence here. This Q-vector divergence of blue. We have two areas of principally of Q-vector convergence. One just off the southeast of Virginia, and the other back over parts of eastern Kentucky and southern West Virginia. Looking at the orientation of the vectors, this is suggestive of the creation of a warm thermal ridge in this region, the way the Q vectors are oriented, in part to this region, these Q vectors. And in the warm sector here, we have actually looks like this will be a diagnostic photolysis actually in this region right here, where the Q vectors are going from warm to cold. Let's go ahead 6 hours on this analysis. It's a little bit messy looking at over the mountains. And it's actually still persists with strong Q vector convergence out to the east. And this is suggestive of the creation of a thermal ridge, or thermal ridge is trying to be created up here. You can see the orientation of the Q vectors. Thermal gradients, this way the Q vectors indicate the time rate of change through the geostrophic motion of the isotherms. So it's trying to rotate these isotherms more like this to create a thermal ridge just off the East Coast. And perhaps even back here over parts of central Virginia as well. But this conspicuous area of Q vector divergence right over the mid-Atlantic is odd. If you look at vertical motion, actually at this point, to see how much of this is actual vertical motion, that's going to be at 700 millibars at 24 hours, I think is what we're just looking at. It actually works out surprisingly well with the Q vector diagnostic. I mean, it's a little bit shifted. This is in a different layer. This is 700 millibars, but off the East Coast of the United States, that's where we saw one of those large Q vector convergence.
We might have been looking at 18 hours.
Okay, let's go back to that. Mess up the maps. This is closer to southeast of Virginia, but or east of the Delmarva, strong Q vector. That's where we see strong vertical motion here. We don't see that area, that nice dipole that we were seeing earlier. And this band of precipitation out here, or band of vertical motion out here, is modestly being tied to a front. You don't see really much here in terms of a shift in the winds in this location. All right, let's go back. Let's go to the surface at 18 hours again. Again, you can see here in the warm sector where we got it. Just along the thermal ridge axis is where we see that. So it's perhaps a weak front here, or a trough that's right here. I guess the main front is where the cold advection is still back off the East Coast. So 1002, let's go ahead to 24 hours. Down to 999 with significant precipitation still located near the center of this cyclone. And the front, as it develops, is developing well out to just off the southeast coast of the United States. So again, a really wet period for the East Coast, and at high to the north, it's low to the south, a strong easterly wind. So the potential for strong wind, maybe some even modest beach erosion is here. We'll check out some maps to see the possibility of that as this cyclone continues to intensify slowly. Let's go to 500 millibars at this time. And at 500 millibars, you can see this nice vorticity maxima right over New York City. But you also see upper trough that was to the west of the cyclone. We saw it earlier over Missouri. Now it's moved to the Ohio Valley. You go from nice cyclonic curvature, positively curved flow, to anticyclonically curved flow, positive to negatively curved flow. It's in this region where we have that sort of inflection point where we expect to see strong upper divergence. The cyclone is located just downstream of that. This is a favorable configuration for some modest deepening. If we were to look at this ridge that's downstream of the cyclone with a curvature changes sign, this is also amplified modestly over time, making this a much more conducive for development. We could go back to 500 millibars at, let's just say 12 hours earlier. You have cyclonically to anticyclonically curved flow. It may be tough to say, maybe if it's tough to see, that maybe it's not that evident, but I'd argue that the curvature has increased just a little bit with the ridge amplifying just a bit. If we take the distance between these two contours, like that, and we go forward 24 hours, yeah, it's about the same. So I guess it really hasn't changed too much in the amplitude, but we have a nice curvature here, which is going to be conducive for this to develop. And we go ahead another 12 hours after this. We still have some change in curvature. It's less positively curved, it's just becoming more anticyclonically curved in this region. And so you might expect the cyclone to sort of maintain itself, but not perhaps intensify much more because the down moves into the wind. So let's look at the surface map at 36 hours. And there it is down to 1,000, still 1,003. So this has actually begun to fill a little bit as it moves to the northeast. But again, a very wet period for the east coast of the United States. For us, we have this light precipitation is forecasted to be out to our west by 0Z tomorrow evening, so 7 p.m. tomorrow evening. Let's go ahead, one more 12-hour period. This is 48 hours, so we're now into early Sunday morning. You can see a trough that's located right over us. Lots of light precipitation. The 540 decameter contour is well to our northwest. We can check some other indications, see are we getting cold enough for any frozen precipitation perhaps on Sunday morning. Kind of doubt it, but we can take a look at that if we look at the vertical profile. Let's quit this. We can go down here and actually look at a surface temperature analysis. Let's go to 48 hours.
I just want to say one thing about that last map we saw, Michael.
Yeah.
The persistence of that the heating that's associated with that starts to look like one of these diabatic
Rossby waves.
Yeah, it's racing away from the cyclone. It doesn't care that it used to be associated with the cyclone. It's on its own now.
And that's an interesting point. So the cyclone center is still here. A geostrophic vorticity maximus is tied to where we see that.
Yeah.
Let's say for precip, and if we were actually to look at the forcing the vertical motion at this point, again, it's choosing the level to look at. We don't have many levels. Let's go to 850 millimeters first. I think the point you made about localized warm advection right here, look at localized warm advection, significant warm advection in this region, which is going to be conducive for in the quasi-geostrophic diagnostics for assets.
Yeah, it's running away from the trough to the southwest.
Right.
Doesn't care
So
about
that's
that
where you're
anymore.
going to see the forcing for some future development.
So then,
Yep.
what's gonna happen to that block that or the very high amplitude ridge that we have now? I was thinking it's gonna kind of run into that and get diverted to the north.
I bet it will.
Just like the last one, okay.
Yeah, I bet it will. I think the ridge is a much more formidable flow feature than this little diabatic wave that's kind of being moved along. It will succumb to the ridge is my guess. I think you're right.
So let's look at, I was going to look at just briefly 48 hours near the surface. So if the forecasted surface temperatures are 6, we're +6. This is going to be in the low 40s if you take these temperatures as they are. So that would probably be at best some light rain showers. I don't think, maybe to the north, not even to the north. It's going to be along when you actually see frozen freezing. And 850 millibar temperatures, just to wrap that up. We'll look at one other view of this. So this is way too warm, way too warm. Yeah, we want to be in these moves way up in the northern part of the state. So liquid precip. Let's go to pivotal for a moment. And we'll check in that broader perspective of those maps, the evolution of that wave that shoots off to the northeast. Okay, let's go to 48 hours and just make sure we're at the same solution, precip type and rate. The northern edge of this storm is forecast to actually have some frozen precipitation, so in Quebec and Ontario. Different evolution in this forecast. It actually brings the cyclone center at 1,002 or just under 1,002 into northern Vermont. It doesn't seem to have that sort of diabatic Rossby wave like feature that we saw in the forecast.
Although we're cut off a little bit, it's not in the same spot. Is there a bigger?
Yeah, let's actually scroll down, please. Continental will go to Continental and then click on that. So we'll see a much broader view. We can see what's going on also out in the Atlantic.
It's still a pretty heavy precipitation feature there, so
Right.
I don't know if it's
not as
concentrated.
obviously where the strongest warm advection
Right,
is.
I agree.
I'd argue that's probably not there. Sort of in the northern part of this.
But I think that ridge at 1038 south of Iceland is going to win.
Yeah.
Yeah, but also it looks like the cold advection is now invading even the northern part of that ridge as well. So this is probably going to be a different evolution. This is another tropical cyclone we'll be watching in Atlantic next Friday. Let's go ahead a few to 72 hours. Let's go a day ahead. See how this has progressed. Yeah, this is really losing its definition here. You do see a region of strong warm advection right here, just near the north of the Labrador Sea. And over us, warm advection is now taken back over. So a nice warm up. And let's go to 96 hours. We're running out of time. I just want to quickly set us up for next week. And there's our tropical weather system out there. And this seems like it's now eventually died. It's sort of still precipitation there, but it's not a very evident, an obvious feature. Let's zoom back in. Finally,
Yeah, three substantial ridges, one on the east coast, one off the west coast, and one south of Greenland. Man.
And a nice sort of mid-latitude cyclone just north of Minnesota. which is going to bring in some cold advection on Tuesday at 96 hours. Let's go, if we could go back to the former view that we had of the continental units. So we got that precip on Sunday, we got another weather system passing by on Tuesday morning, wind shifting back to the northwest, so we begin to cool off. Let's go to 120 hours, we'll just go this a day at a time. Over much of the US, it's going to be relatively quiet. Cold advection takes over, so we're going to be beginning to low thickness advection. So those of you at 310, we talked a little bit about thickness. We're going to see the average temperature over us dropping a bit.
It looks like a big snowstorm developing in Colorado.
Yeah, with the easterly flow, upslope. Could be
The classic locational low on Four Corners.
down here, so that's going to be a nice setup.
Oh, yeah, look at that.
Look at that, and it intensifies. You can see the precip amounts of it, or the intensity of the precip has gone up, is getting darker blue. Just as this easterly flow hits the Rocky Mountains, you're getting that flow set up. And across all of Kansas, what is it, about 1,000 foot or 2,000 foot increase in elevation as you go from
I
east
think
to
it's
west?
almost 3,000.
3,000
Yeah.
feet across Kansas. So even though it looks like a pretty flat state, as you go from east to west, you're actually increasing it up.
Yeah.
So this one could get Denver. I think the MMS was putting down up to 12 to 18 inches.
Yeah.
Yeah, here, it's
Maybe
like
not in the
south
city.
of Colorado Springs, looks like they're getting the heaviest snow in the southeast.
Well, at that point, but as the Kelvin wave progresses, it's going to drop a lot on the Palmer Lake Divide, the north side.
So let's watch what happens just a little bit further. That's 132 hours, go to 144.
Oh.
Here's the cyclone developing. It's moved away out of Colorado. The western edge of it has snow. This is Thursday morning. Let's go ahead slowly, just slowly. Don't want to give it away.
6 or 12.
6. Let's prolong the angle. All right. So there's a cyclone just south of Missouri, and then we see the northwestern edge of it over eastern Kansas. It's snow. We're largely cold here. We can look at we'll do one more click before we get there. So this is now 0Z on Thursday, 7 p.m. Thursday night. If we just click on here, roughly where Madison is, right about here. Just click, we can get a thermal profile. So here are isotherms. Here's the 0 degree line. Okay, these blue lines.
Saturated up to 250 millimeters. Is that what this is?
Yeah, this says on the 300. Yeah,
It's a little extreme.
but surface temperature 37. We're largely cold enough for precip. The best guess for precipitation type one based on the sounding is for snow. So this is on Thursday evening, 7 p.m. Time to get provisions. Then I've got 162 hours, so this is at 1 a.m. on Friday. Cyclone still to our southeast, northeast wind. This is a snow event. It may not be as impressive in terms of the snowfall rate,
It's a snow
but to
event.
call it, use the word significant or something?
Did I? I might have said that. It was a significant snow event. I think it caused people to snarl up in traffic and whatnot.
Yeah, that's not, I mean, 20 minutes of.
Everyone on Regent Street was a little grumpy.
They were
Yeah.
rubbing, see?
So 168.
Yeah.
So yeah, some solid stuff. We look at the, doing another click here to see the precip type.
This is
But I-
another, almost no cyclogenesis. The thing stays around 1,000
Right.
millimeters the whole time.
Sometimes those are the heaviest snow.
They are, usually.
Yes. And again, 33 or so. So this would be, the grassy areas might, if this were to verify. But what's, we're looking at one forecast. That's one problem with what we've just done. It's 168 hours ahead, but that's never stopped me before, right? So click on that.
That's for sure.
We can look at, if we just go back and sort of look at how the forecast changed since 6 hours ago for the same time. Right. Maybe it's a little bit faster, so we can go back a little bit. The timing might be a little bit off. It's sort of a colder forecast. Keep going back a little bit.
More intense cyclone.
More intense cyclone. It has rain over us at this point. We're gonna have to also look at the sounding of this. So there is a degree of uncertainty certainly in this forecast, even just comparing these two runs. Even at that time, we have a surface temperature of 41, I guess, a wet bulb of probably 37 or something. And still, I would say arguably it could still possibly be, even though it looks like liquid precipitation, this could be still snow, given that forecast. And we will click one more back. Let's go back to 174 on this, and then let's go back to 0Z. Yeah, it's really a different forecast. The nature of the forecast has changed. Let's finally look at another, just a totally different model. Go to the GDPS, which is the Canadian model, roughly the same time. That's in a different universe. This is
It's gonna get 12Z.
Yeah, everything's done.
Doesn't have the cyclone as well developed, as much further to the southeast. So there's a lot of uncertainty that still exists with this, but we're certainly heading into a pattern that's gonna be more conducive to snowfall. And lastly, go back to GFS. And we'll just, 12Z, let's just go to the end of the period. I don't know. Jump up.
Oh, High Plains blizzard.
Right, but again, probably didn't exist.
It's a Veterans Day storm. Wow.
Oh, yeah, 11/11.
Wow.
How do the two GFSs differ? The new GFS and the old GFS?
Oh, you mean the GF FP3? So this is just beginning to come out in terms of the forecast. So this model that we're looking at right here, the GFS FP3 is what's called a finite volume model. It's going to become the new global forecast model for the U.S. Weather Service starting, I think, in January. They've already sort of checked off the boxes to say they've approved it. Interestingly enough, its forecast for tropical cyclones this season was dwarfed by the success of the actual current GFS model that we have. So it's not as accurate with that, but positive activity might be the closest we get. In fact, even the GFS, the one that we're about to retire, I think beat the ECWF for this season.
Oh, is that right?
So a lot of things have been improved in it.
Yeah.
Right? Now they finally got it right, we're gonna switch to a different model, so it's all right. In fact, those statistics, I think that's more anecdotal. We wait until we get to the end of the season and look at everything, the verification, but on a number of events, it seemed like it did a little bit better. So I'm not gonna criticize no on that decision, but they've looked at it, it's ready to go. We don't have all the same products yet for this on the pivotal site, and I guess we'll be getting this through the conduit feed. Do we get FP3 now on the conduit feed?
I don't know if it's out there now.
But if people are interested in doing statistics on verification of the models, that's something that we could possibly look at. So this is the 180-hour forecast from 0Z last night. If you want to compare it with the GFS, we can go here, click on GFS, just to see, do we have a similar pattern?
Yes.
It's somewhat similar. It's the shifting of the location of the trough along the East Coast. We can look at another model. The Canadian model will also be available for this. That's different.
That's pretty different.
That's different from trough to ridge and East WF at the same time. It's more like this.
Yeah, it's like Canadian.
Right. So, some differences. There's a couple things. You'll see a poster for those of you that are juniors, seniors, or grad students. A poster will be going up later this, sometime next week, early in November, for a class that's going to be offered 401, 801. It'll be called sort of practical numerical weather prediction. You have an opportunity to learn how to run forecast model. We'll probably stick with the WRF model, but we'll be looking at issues related to post-processing, verifying the model, doing some interesting statistics with the output of the model. And so if you're interested in learning something about how to run a model, post-process the output and do some interesting science with it, that's a course to consider. So there'll be limited enrollment for the first time we offer this, but we'll also hope to do some data simulation in that as well. So how to get data to models. All right. Well, thank you, John. Thank you. Thank you all for coming.
Wow, it's snowing.
Right. You want to bet on that? That it'll actually be snowing?
Negative. I never bet on things I want to happen.